Good morning. So today we're going to talk about leukemia risks for a Mars mission, and we're using a dynamical approach, which differs from the conventional approach. I'll mention that in a second. And this is a collaboration with Dr. Olga Smirnova, who's retired in Moscow, Russia, and myself at University of Nevada, Las Vegas. So the question of leukemia risk is important because it has one of the highest excess relative risk per gray for radiation-induced cancers, and while at the same time the shortest latency, so that it has been observed as early as 6 months post-irradiation. In some populations, average about 2 years. So this is much shorter than solid cancers. The model is based on a system of nonlinear ordinary differential equation, with the nonlinear piece corresponds to a negative feedback of transient amplifying cells and differentiated cells on stem cell proliferation. So the model we're looking at is for the granulocytes to represent acute myeloid leukemia, and lymphocytes be involved in lymphocytic leukemias. Don't have time to give the details. The concentration of damaged cells is then related to the excess relative risk you can see in our publications. Here are some predictions for leukemia risk and dose rate. The left shows the versus the concentration of damaged cells in comparison to different populations, and the right graph shows versus cumulative dose at different dose rates. So what we're saying is that the linear model, based on the extrapolation from high to low doses, overestimates, and that the error will increase as the dose rate is increased. Now, this graph shows predictions for a Mars mission, where the diamond at the lowest cumulative dose, just under 1 sievert for a Mars mission, agrees fairly well with the linear model, but then the other symbols represent different scenarios for solar particle events. We're using the doses from the August 72, November 60, and September, October 1989 events for typical spacecraft shielding. You can see the linear model does relatively worse as you include the GCR in combination with solar particle events rather than just adding up the doses. So the previous work, again, shows that the RBE for leukemias is much lower than solid cancers. This was included in my previous work, the NSCR model. And we now show that the linear model overestimates because of the dynamics of the processes involved in how stem cells evolve into cancers such as leukemia. Future work will include the dynamic leukemia model into the NSCR model version 2021. And then we're also working on investigating the alteration of immune responses due to microgravity and potential effects on blood system responses to space radiation. I want to point out there's a book that has some of the details of Olga's work that was published in 2017 as a second edition. Thank you.